All right, moving on to projectiles. This is just like a quick review sheet on 2D motion, so we'll go through these really quick. All right, so somebody's throwing a baseball up. This is like a projectile launched at an angle. So what's the velocity doing in the first half? Okay, the velocity value is actually decreasing because every second it's slowing down by 9.8 meters per second. Remember, it's going to slow till it hits this zero value at the top, and then it changes direction and starts speeding up, coming back down. What's the magnitude at the top? It's going to be 0 because that's where it changes direction. It's still accelerating there, okay? Gravity's still acting on it. It's slowed down to the point where it crosses a 0 value. A man walks 5 meters east, 10 meters west, east again for 25 meters. What is his displacement? So this is where we do 5 minus 10 plus 25, okay? Because displacement's a vector, we got to take direction into account. So let's see, that's 30 minus 10 is 20 meters. And his overall direction is going to be east, because he started at 5 meters. Imagine he went 5 meters, then he went 10 meters west, but then he goes 25 meters east. So he's going to end up east of his starting point, 20 meters east. A plane tries to fly north at 100 meters per second with a tailwind that blows north. What is its resultant speed? So it's flying north, but then there's also a wind blowing it, and the wind's blowing it in the same direction. So those are going to add up. Okay, so he's going to end up with 120 meters per second because the wind is, in this case, the wind is adding to his speed because it's in the same direction he's going. Which would be considered a projectile? Let's see, a car driving, an airplane taking off, a rocket accelerating through space, a ball rolling on a table. Okay, so projectile is an object in free fall. Only gravity is acting on it. Okay. So I would say an airplane taking off could be considered a projectile if we don't think about the other forces. The car is on a highway, it's not in free fall. The ball is also not in free fall. The rocket in space, there's not going to be gravity, depending on where it's at. So I don't know, the airplane's the closest thing. Difference between vectors and scalars, we talked about that in the last video. Vectors have direction. That's the big difference there, okay? Scalars don't have any direction, they're just a number. Vectors have a number value, but they also have direction. A ball is fired horizontally from a cannon at the same time as another ball is dropped from the same height, which hits the ground first. They will hit the ground at the same time. Remember, time in the air depends on height. That was this equation. I can draw 2 times dy over g. Remember that one that we looked at a bunch of times? Height is what determines our time in the air, and they're, even though one is fired, so it's got a horizontal velocity, the other one's just dropped, they're at the same height. The horizontal component of a projectile's velocity is independent from its vertical component. Remember, those two motions are independent of each other, but we need both of them. The projectile's got motion in the x direction, it's got motion in the y direction, but we need both of them to describe it. Boat is rowed at 6 meters north across a river that flows east. What is its resultant speed? Okay, so this is where we want this hypotenuse. We got to use the Pythagorean theorem here. 3 squared plus 6 squared equals, I'll just call it c squared. What we're doing here is this velocity is going to have some north component because the boat is being rowed in that direction, but it's also going to have some east because of the river flowing. So we're getting the combination of those, which is our hypotenuse. Okay, so let's see, 3 squared is 9 plus 6 squared is 36. So 45 equals c squared. And I need to take the square root of 45 to give me c, which is also my velocity there. So let's see, let me do that really quick on my, I'm doing this on my phone calculator, so, because I have to find my regular calculator. I have moved all kinds of things around for Thanksgiving. 6.7, so 6.7 meters per second would be this value. Okay. All right. Big rock thrown up at an angle, small rock thrown straight up to the same height, which stays in the air for more time. Again, they're going to spend the same amount of time in the air because they're thrown to the same height. Which sounds goofy, but time in the air depends on your height when you're in free fall. All right, when is the acceleration of gravity equal to 10 meters per second per second? That's rounded. Object falling down, object thrown straight up, object thrown at an angle, all of them. For all of these objects that have the same acceleration due to gravity, okay? That also, again, explains number 10. It's the same acceleration due to gravity. Okay,